This is today's lecture. We're going to go with section 2.3. Now, remember, today is also our quiz, and that has to be finished before the end of this, before 5:15. So do that first, right? Don't give yourself the time to do the quiz and then listen to the lecture. You have the whole day to listen to the lecture. Okay, so we continue with determinants and matrices. Okay, so what do we have so far? We have two ways of finding review. I'll do a quick review here. So a review is that we have the determinant of a matrix. We can either do row expanding along a row, or reducing, row reducing. The two methods, and the best method is actually a combination of both. That's what we did in last section. Okay, and this was also your homework for today. Okay. Now I'm going to get more interested in the following problem. What about the inverse of A? Remember, we had a formula. Let me write down again the formula. If A is the 2 by 2 matrix, A, B, C, D, then there are two parts to find the inverse. The first one was the determinant. That was AD minus BC, but we now have given this a name, right? This is what we call the determinant of A. That was the factor. And then we did something weird here. What we did was we exchanged some numbers. We exchanged these two numbers, so we would D and A here. And then these two numbers, the off diagonals, are in the same spot, but with a negative sign. So that's how we calculate that. And what we're going to do today is a generalization of this, but you'll see it's much more tricky than that. And I'll leave it as an exercise for you to see that once you have learned the method today, check that it actually is the same as what we're doing here. Okay, so how does it work? Well, we're going to use, there are two things, right? We have this determinant of A, and so this is of course clear because we're going to divide by it. This is already something that we can write down. A matrix is invertible. This can only be if the determinant, and this is how we write it in mathematics, if the determinant is non-zero. If you're a bit wondering what this means, it means on either side of what I'm saying has the same value. They're so-called equivalent. So for a matrix to be invertible, its determinant should be non-zero and vice versa. Okay. So this is about this determinant, but what is this kind of matrix? Where does this come from? And you'll see this is what we will call the adjoint of a matrix. So I'm going to define the adjoint of a matrix. I'm going to write this adj of A. And the definition is, I'm going to write it in words, but I'll work it out and you'll see what it is. It's going to be, well, the transpose, we'll talk about again what that is, of the matrix of cofactors. Now the cofactors, I might have forgotten a little bit what it is, but I'll review everything. Okay, so the way to explain this is best to work on an example. And so my matrix that I'm going to work with is, I'm taking a matrix that's an example from the book, so you can double check your later then. 6, 3, 2, minus 4, 0. So what are these cofactors? Well, let's do an example of a cofactor. And I'm going to pick one of the 9 elements. Let's pick this element. What element are we talking about? That is, if we would give if you want the coordinates of that element, and where is it located in our list? How do we mark it? Well, it's in the 3rd row and in the 2nd column. That's why we write A32. All right? So we say that this is A32. And now, what is then C32? Remember the cofactor of this guy? The cofactor of A32, that was what we called C32. And how did we do that? Well, there were two parts of it. So C32, it was you take this element, and first, sorry, let me make this a little bit, let me do it in a different color. You take this element, and then we first have to figure out the cofactors. Remember, cofactors, they have a sign. Don't forget the sign here. The sign comes from this pattern, this, if you want the check pattern here, plus, minus, plus, minus, plus, minus, plus, minus, plus. So this one has a minus sign, so that's the minus here. So this minus comes from the fact that that's a minus position, if you want, okay? Good, so, and what else? Well, then we scratch out the element, the row and the column it belongs to. In other words, the third row and the second column, that's what we scratch out, and we left 3 minus 1, 1, 3, correct? Okay, but let me undo this. You know, by the way, I'm using Notability here. That makes it so easy for me to undo things. You might want to look it up and see whether you can use that too, but it's unfortunately not a free app. Okay, here we are. So that's my first cofactor. Well, I have to work it out, so let's do this. Minus. Product of these two is 9, and then you subtract the product of these two, right? That is minus 1. So the whole thing is minus minus, so it's 10 is minus 10. So that's one of the cofactors. But I'm saying it's a matrix of all cofactors, so I'm going to actually calculate all of them, okay? It's a good spot to stop the movie, pause the movie, and then try to do it for yourself, and then verify that you've got the same answers, that you understand what is going. What I'm going to calculate is, I'm going to calculate C11, C12, all of them, all 9 of them. Okay, C11. We're talking about first row, first column. That's with a plus sign. I'm going to write it, but it's of course silly to write. But what do we left? Well, the matrix 6, 3, minus 4, 0, right? Okay. 6, 3, minus 4, minus 4, 0. So that is 0 minus this product is negative 12. So the whole thing is 12. C1, 2. You can do whatever order you want them. I'm not sure that I have all 9 of them. I'm going to do C1, 2. What is this? First row, second column. We're talking about this guy. That's a negative sign. And then if I scratch out, I see 1, 3, 2, 0. 1, 3, 2, 0. That is minus. This product is, this is 0 minus 6. So that is 6. C1, 3. We're back in the plus sign. And the matrix we got is 1, 6, 2, minus 4. 1, 6, 2, negative 4. That is negative 4 minus 12. That is negative 16. All right. Well, I did the first row, so let's do the second row now. C2, 1. We're talking about this element. So scratch it out, sketch it out. 2 minus 1, minus 4, 0. We set a minus sign, right? Yes. 2 minus 1, minus 4, 0. So that is minus, and then this is 0, minus, and then this product is 4. So the whole thing is just 4. What else? C2, 2. Okay, I'm going to try to get everything on the same page here. C2, 2, that is the one here. It gets a little bit murky already, but this actually is a plus sign. Okay, so this comes with a plus sign. I'm not going to write this anymore. If we scratch out, we get 3 minus 1, 2, 0. 3 minus 1, 2, 0. So that determinant is minus 2. 0 minus 2, so that is 2. C2, 3, let's do this here. C2, 3. Again, a negative sign. These things kind of change, alternate, right? Okay, so that's the matrix that I get 3, 2, 2 minus 4. 3, 2, 2, negative 4. So that is minus. This product is negative 12. Subtract from that this product. So negative 16, negative 16, that is 16. C3, 2 I've run done, so let's try to do C3, 1. Squeeze it in here. C3, 1. Third row, first element, that's with a plus sign. And what I'm left with is 2 minus 1, 6, 3. 2 minus 1, 6, 3. So that would be 6 minus minus 6, that's 12. Okay, and then finally C32F, so 3, 3, 3, it's again with a plus sign, you see that, okay, there's a plus sign, sketch out, and we have 3, 2, 1, 6, so this is 18 minus 2, this is 16. Okay, so I have calculated all 9 of them. I'm going to put them now in a matrix. So here's my matrix. So this is the matrix C11, C12, C13. Remember, the first index indicates the row. So what's this one then? C21, C22, C23, right? And the next one, C31, C32, C33. Make sure that you know where these things go. I mean, what you need to do is to plug these guys in. So this is the matrix of cofactors, but whoa, there was another word here, right? Let's not forget this word here, transpose. So we have to take the transpose of this matrix. Okay, so let's see what is gives me what is in this particular case. So this would be the adjoint of the matrix, right? The adjoint of A is defined this way. Okay, in our case, let's make the list of numbers that we have. Let's scroll down a little bit. So C11, okay, C11, that is this position, 12. C12, I hope everybody sees. C12, that is this position, 6, right? C13, minus 16, that is here. C21 is here, right, 4. Let me pick another one so that you don't have to do it in order. You can do it in which order you want. Let's pick C33. Where C33 goes? Well, third row, third column. So it goes there, all right? So that was 16, all right? There's that. C31, that's 12, that goes here. You see that? Okay. What else? Make sure that you don't forget anyone. C32, that would be in the middle here, right? C32, that's minus 10. C22, that would be the middle one here, so that's 2. And then finally C23, that would be 16, that goes there. But transpose. What does that mean, transpose? Well, transpose means that the rows becomes the columns, and the columns becomes the rows, in the same order. Some of you on the test just did the order wrong. Okay, don't do that. So it's really, what you do is you take this line here, and you flip the matrix along that line, flip it over. So this would be now 12, 6, 9, negative 16, and then you would have 4, 2, 16, and then you had 12 minus 10, 16. So that's my adjoint of A. Okay, so good. What is this now good for, you might ask? Well, before we go on, what's the determinant of A? We haven't actually talked about that. It's kind of a bit of a nasty one. We could do a reduction, or we could do expansion along a row. If you do a row column, I would definitely use this one, or either this one, to have at least 1 0 in there. But let me do row reduction to show you that this actually is more elegant. Okay, so this is adjoint of A. I'm going to come back to it. I'll put it out of sight, but I'm going to now calculate the determinant of A separately. So what was the determinant of A? Trust me, that is the same A. 3, 2, negative 1, 1, 6, 3, 2, negative 4, 0. I'm going to do row reduction. And remember, the technique of row reduction is a little bit flexible. I don't really have to make an echelon form. I am using whatever pivot that I have. I have this pivot here, and with this one, I can make a 0 there, and I can make a 0 there. Of course, I have to do this using valid row operations. So one of valid operation is that replace row 1 by row 1 minus 3 times row 2, right? It is to get a 0 here, I have to multiply this element with negative 3 and add it up there. That's what this does, okay? And then at the same time for row 3, there I have to now replace row 3 by 2 times row 2. And these row operations do not change the determinant, so I really have equality here. So we have now that is the same as, what do I get if I do these row operations? So let's do this one. So we have to multiply this with negative 3 and then add up there. So that would be a 0 there. Negative 3 times 16 that is negative 18, plus 2 is negative 16. Negative 3 times 3 is negative 9, plus minus 1 is minus 10. This row is what it is. And then now I multiply with negative 2 and add up there, so I get a 0 there. Minus 12 plus minus 4 is minus 16. Minus 6 plus 0 is minus 6. This is what I get. And what is the whole thing now? Well, you have a column in which there's only one non-zero element, so we expand along this column. So now we do expansion along column 1. But don't forget, okay, we have the pluses and minuses, right? This is a plus, this is a minus, this is a plus. So this is actually a minus, okay. So we have minus, and what we have left with is negative 16, negative 10, negative 16, negative 6. All right, so that is minus, a lot of negatives, but okay. Negative 6 times negative 16, that is 96. Minus, and this product is 160. So if I subtract these things, I'm doing this in my head, I'm going to regret this, but okay, minus 64, so actually 64. Okay, so we have now done two things. We calculated the determinant of A, so let me write down. The determinant of A is 64. And the adjoint of A is this matrix. And now is my claim is that putting these two together, the inverse of A is equal to, you take the reciprocal of the determinant, and then the matrix that you have is the adjoint matrix. So coming back to our original 2 by 2 matrices, here we divide by the determinant, and this is the adjoint of A. Please verify this. It's kind of weird because there are no cofactors really, but so it's a good exercise to check that this actually does what it's supposed to be doing. Okay. So this is the formula. Well, okay, I don't believe you, you might say. Well, let's work it out in this one particular case. Oh, the numbers are going to be too big, so I'm not actually want to do this. But so, homework. Well, no, not work. Let's say, try yourself. Well, we have here a adjoint of A. We have this one, and what does it mean that this would be a determinant? That A times A, this new guy that we get. So this, okay. So what is this matrix in this case? Sorry, let me perhaps write that down first. So in our particular case that we just calculate, what we get, we have 1 over 64, and then the matrix is 12, 4, 12, 6, 2, negative 10, minus 16, 16, 16. And remember that this 1 over 64 in a matrix means every single element would be divided by 64. Okay, and so check now that this should be the identity matrix, right? We call that I. That's what we call it, right? I or I3 or just I. So check out that if you multiply this matrix with the original matrix that we had here, the original one, where is he? Here, well, it's almost invisible there, but it's this matrix, right? So if you multiply these two, that you actually get the identity matrix. It's not clear at all, right? Because look, these numbers are so big, it doesn't look that it's going to work, but it actually does. Okay, so that is the method of the adjoint of a matrix to find the inverse of a matrix. But you see, it is kind of quite involved, right? It's a lot of, we have to calculate all these cofactors here. And then we also have to calculate the determinant, which means basically doing row reductions. Why not just do the method, the original method, the method from last time, the method where you do row reduction on the matrix, and next to it you put the invertible matrix, the identity matrix, and then row reduce that one. The method that we did in the first chapter. That sounds a much easier way of doing it, right? But okay, it's good to have different methods. Okay, that's the adjoint of a matrix. There will be some homework problems on that. And then this topic had two things that we want to discuss. Cramer's rule, and again, it's a little bit a lot of writing, so it's not very practical, but sometimes people use this. And so what we want to do is solve a system of equations. So I'm going to again work with an example. Okay, so it's a little bit of calculations, but let's do it. It's good to do some calculations here. Suppose we have to solve this system of equations. Minus 3x1 plus 4x2 plus 6x3 is 30, and minus x1 minus 2x2 plus 3x3 is 8. Okay, so the matrix of this system is this the matrix that you get from looking here at the coefficients. The first row will have the coefficients of x1, so this will be 1, -3, -1. The second row will be the coefficients of x2, where there is nothing here, so there's a 0 there, 4 and -2, and then the last row is 2, 6, 3. Okay, and so what was the method that so our previous method was the row reduction method. Let me quickly remind you how it went. We took this matrix 1, 0, 2, -3, 4, 6, -1, -2, 3, and then we put in this last column 6, 30, and 8. Okay, so this 6, 30, and 8, these are the constants here. Okay, and this is we put there, and then we row reduced, and once we have this guy in echelon form, we can read off the equation. And we also notice that if this matrix happens to be invertible, and this is an example of invertible matrix, then there was a unique solution. Namely, one thing you could do is calculate a minus 1. So one method, let me write it this way. So that one method was row reduction. The other method was calculate a minus 1. Of course, this can only be done if a is invertible, otherwise it doesn't work. Calculate a minus 1, and then you multiply a minus 1 with this column, 6, 38. And that's then the solution. Go back to see that this is what we did then. And now I'm going to do a third method, and this is what we call Cramer's method. It's again not going to be very practical, because it involves quite a lot of determinants calculating, but it is really that. We're only going to calculate determinants. And what do we do now? Well, first of all, let's calculate the determinant of A. For the Cramer's method, we need two things. We need the determinant of A. Let's do that first. Okay, so the determinant of A, our matrix was 1, 0, 2, -3, 4, 6, -1, -2, 3. And we're going to have to do quite a lot of determinants, as I said. So let's do perhaps, for a change, let's do expansion and row 1. Let me just write it as row 1. Okay, so expanding around this one. So we have 1 times what is left is 4, 6, -2, 3. Do you see that? We have to keep track of the signs. Let's do this plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is 0 with negative sign, so actually I don't need to write it. And then we have this one, so plus 2, and what is left is -3, 4, -1, -2. Okay, so I can work this out now, what this is. So this is 12 minus -12 plus 2 times -6 minus -4. So this is 24, and that is plus 20, so I get 44. Yep, that's correct. Okay. that's the first thing, the determinant of A. But we're going to calculate more determinants. And so remember, what I'm trying to find is, I find the solution which we can denote here, this the solution here that we want. One way of saying that is x1, x2, x3, right? That is what we want. We want to find this. Remember, if you have this matrix, then this says that A times the column x1, x2, x3 is equal to this column 6, 38. This column here. Okay? That's what it means to be the matrix of a system of equations. Okay. So, what am I going to do next? I'm going to calculate what the value of x1 is. And the value of x1 is going to be the determinant of a1. Let me write it with determinant. The determinant of a1, but I haven't told you what that is yet, divided by the determinant of a. Now this we calculated. What is this a1? So what is a1 is obtained from a by replacing this column, the column replacing, let me write that, column 1, by what? We're going to replace it by the constants. What do I mean with that? So let me use a different color for that. What I mean with the constants, so the constants here, what is this? This is exactly this guy here, right? The one that we normally write in the back. So this is what I'm saying. Replace, so let's do this. Let's work out what I'm saying is, I have the matrix A, so I'll write it again. Where was my matrix? Here, right? 1, 0, 2, negative 3, 4, 6, minus 1, minus 2, 3. And so what is A1 now? In A1 is you delete this row. So I'm going to erase it. And then plug in the constants. That was this column, 638. 638. That's it. And so of this matrix, I have to calculate the determinant. Well, let's do this again with row reduction, with expansion. So I'm going to do this expanding again along row 1. Okay, that seems to be the simplest way of doing. You see here, if I would need to do a row reduction, I don't really have a good pivot. So perhaps this time I'm better off doing this method. Okay, so we expand again along this row. So we get 6, remember, plus, minus, plus. So both will be pluses here. What is left is 4, 6, negative 2, 3. I hope you see this, right? This is this guy, all right? And then plus 2. And what is left? Okay, 34, 8 minus 2. 34, 8, and negative 2. So, let's work this out. 12 minus 12 plus 2 times minus 60 minus 32. Okay, so that is 24 times 6, 24 times 6, 120, 144. And this is minus 92, twice is minus 184. So the result is negative 40. And so what do I have? That's the determinant of A1. That's what I just calculated. So that's this guy, minus 40. And what was the determinant of A? The determinant of A we found was 44. So this is the solution. This is the first element of the solution. So this calculates x1 without knowing what x2 and x3 is. So how do we get x2 and x3? Well, perhaps you can start guessing now what we need to do. We're going to do exactly the same thing here. So let me erase a little bit. Sorry. Well, that's the only thing I have to do. Change the column. So AI will be obtained from I by replacing column I by the constants. That's the only thing I do. So I'm going to, this is the guy that will come instead of each of these columns. So what is A2? Okay, let's write down what A2 is. So A2, well, start with the original matrix, which is, okay, I'm gonna copy it from my notes here, because otherwise, okay, it's 1, 0, 2, negative 3, 4, 6, minus 1, minus 2, 3. So A2 means this row is to go now. And instead we plug in the purple guys, right? So I mean these guys here, the pink, sorry, it's pink. 6, 38. This is A2, so what I need to calculate is the determinant of this guy. So what is the determinant? One, 6, 2, negative 3, 36, minus 1, 8, 3. This time I'm thinking, I don't see any zeros. I'm going to do row reduction because I have a nice pivot here. So, okay, let's do that. All right, so I'm going to do, I hope you see how to do this. Do this yourself before you continue with this movie. 2 plus 3 times row 1, row 3, row 3 plus row 1. These are row operations that do not change the sign, so we get 1, 6, 2. If I multiply this row with 3 and add to this next one, I get 0. 18 plus 30 is 48, and 6 plus 6 is 12. And now I just add these two rows here, that's the next one, so that is 0, 14, 5. Okay, so I expand along row and column. This is a 1, that's so nothing to do. This is also plus, so 48, 12, 14, 5. You see, these are rather big numbers, and if we would have to do, no, okay, they are very big numbers, what can I say? So 48 times 5, that is 240, minus 14 times 12, okay, it's getting late, I don't know exactly, 144, 168, and so the whole thing therefore should be 72. Yep, I got it right, 72. So that is the determinant of A2. And so what does this do? Well, X2, so remember AI, oh, yeah, right. So what I meant to say is you calculate AI, oh, shoot, not do this. You calculate AI, and then you find, if you calculate AI in the formula, you now replace 1 by, sorry, this is a little bit, my thing is too big. Okay. You let me just write it off, because otherwise I'm getting. So this AI. So okay, let me write it over again. So we know now that X2 is the determinant of A2 divided by the determinant of A. That stays the same, which is 44. We had already calculated, and this one we calculated was 72. And there is the coordinate of X2. Okay, so please try to find what the coordinate of X3 is. I'll show it, but you should try it by yourself now. So we have to calculate the determinant of A3. I start with writing the original matrix, which was 1, 0, 2, minus 3, 4, 6, minus 1, minus 2, 3. It's a lot of writing, right? And then this row is going to be replaced by the column row, okay? So my column row, that was, let's keep the nice pink, that was 638. That's so always we put this column in. And you see the column moves, so to speak, through the matrix, right? Okay, and now we calculate. Well, I could do expansion now on the first row again if you want. Let's do I like the row reduction. I don't know about you guys. I'm going to do row reduction. So I'm going to do row 3. Row 2 is row 2 plus 3 times row 1, and row 3 is row 3 plus row 1. the kind of the same rows expansion, the same operations as the previous case. Okay, what we get, let me think, this is a 1, this is a plus, right? So this, oh no, sorry, that's not what I'm trying to say. I have to do the row operations, sorry, I'm going too fast. Here are the row operations, that's 0. So multiply this row with 3 and add up that, so that's nothing there. And then 18 plus 30, that's 48. And now we add these two rows, that's a 0, that's a negative 2, and that's a 14. Okay, now I do row expansion along the first column, but let me not write it anymore. I hope everyone sees what I'm doing. So there's 4, 48, negative 2, 14. That is 4 times 14 is 56, minus, there's a minus here, and this is going to be 96. So 56 minus 96, 56 plus 96, that is 152. Okay, so 152, and therefore x3 is, I write it up again, determinant of a3 divided by the determinant of a. Determinant of a3 we just calculated is 152, that's this one, and determinant of a, if you don't believe me anymore, we calculated was 44. All right. So that is Cramer's rule, and I'm going to give you an exercise to try to do this as well. As I said, it's a bit of writing, but it is a good exercise to see that you understand all the various methods and that you be smart in calculating your determinants. And I did this bit at 3 by 3, but you can do this actually with any n by n matrix, and of course then you would have A1, A2, A3, A4, and so on, as many as there are rows. Okay, and I repeat, what are they? The AIs are just the matrices that you get by replacing the ith column by the column of constants. It's pretty simple, straightforward technique. Okay, don't forget to write a comment with your name after you watch this movie. I think people keep forgetting that, and there's no way for me to check if you don't. So if you think you might have forgotten, go back to the previous movies and see what you actually left a comment. I don't know how you can. There must be ways in YouTube that you can quickly do this, but if you have watched the movie and forgot to put a comment, do it as quickly as possible. I normally see all my comments coming on, so don't forget that, please. Otherwise, I have no idea that you actually watched the movie.